Okay, so we're talking about how we are going to consider point O and B in the coordinate plane. We're going to try to figure out how we're going to do this. So, everybody tell me where point B is. 3, 6. Okay, so we know that it has a coordinate point. Everybody agree or disagree? Okay, we have a coordinate point. On the side, I want you to write that coordinate point. Just over here on the side somewhere, write 3, 6. Three, 6. Okay, so we know that this point lives on the coordinate graph at 3, 6. Everybody good? Okay, now it says that we want to choose a scale factor card. Well, I just gave you these little pieces of paper. So we're going to work through these together because we're going to look at this in a way that is going to hopefully make perfect sense. Pick up your head, please. And we are going to allow for our brains to see it the way that we need to. So if we're given a scale factor, we know that what do we have to do with scale factors? What's our job? We have to multiply with scale factors. Yes? Okay. So when we're multiplying with scale factors, is there a problem? So with scale factors, we have to do what? Multiply. So we're multiplying something. But our decision now is to figure out what we need to multiply by. So we have a scale factor. What do y'all think if the information that we've been given is 3, 6? What should we possibly multiply by? Do what?
We can multiply by any of the 4.
Any of the 4 what? Okay, well, we have a scale factor. If I choose this scale factor, what am I multiplying this scale factor times?
You're multiplying
Both of the what? What do y'all think? Y'all help Carter out.
I got the dimension. I don't know what it is.
What are the what? The coordinates. So, ready? That's the only other option we have. That's the only thing that we could possibly be multiplying by would be the coordinates multiplying by the scale factor. Ta-da, you figured out the whole lesson. Watch. Really? I'm not kidding. I know. Okay, if you did your Zern, you should be able to do this. Okay, so ready? If our coordinate point is 3, 6, and our scale factor that we're going to use is 1/3. Scale factor that we're going to use is 1/3. The way that we're going to do this is you're going to take each coordinate point and you're going to multiply your x coordinate by the scale factor and you're going to multiply your y coordinate by the scale factor. So that's going to look like this. 1/3 times 3, 1/3 times 6. You should be writing what I'm writing. Thank you. So, what's 1/3 times 3? 1. And what's 1/3 times 6? 2. So our new B coordinate point is going to be at coordinate points number 1, 2. So this is B prime. If we were to use a scale factor of 1/3. Y'all okay with this? Okay. So what I want you to do is I want you to do the next 3 scale factors with that same coordinate point exactly the way that we did it. Exactly the way that we did it. So you're taking your scale factor with the original coordinate point, so the coordinate point didn't change. And now you are going to multiply, Cameron, your scale factors times your coordinate points. I'll give you about 2 minutes to complete it. Okay, so what did y'all get for 3 and whenever we multiply times the scale factor of 2/3? What did y'all get for your B prime? 2, 4? Okay, and what did you get for whenever you multiply times the scale factor of 2? 6, 12. Okay, and what happens whenever we have 3, 6? 9, 18. Okay. So our job now is to look for a pattern within each row and table. What do you notice about the relationship between the scale factor and the coordinates? So we're just looking for a relationship. What do you notice about them? Yes, ma'am. What you mean? Like if you plotted them? Yes. Okay. So let's look. So we have 1, 2. We have 2, 4, we have 6, 12, and we have 9, 18. Okay, those were the 4 that we just did, right? What do you notice about all of them, though? Yes, ma'am. Okay, so we're multiplying the scale factor by both things. Let's sit up tall. Let's pay attention. It's Monday. We're going to finish the week strong. You're going to have a test this week. We're going to have an activity this week. We're going to be doing all the things. We're not going to stop working because we have a break coming up. Yes, ma'am. Okay, it keeps enlarging. Okay, what else? I'm looking for a specific word. We used it a lot last week. Okay, we're dilating. There was another word, though. Yes. It's enlarging. Okay.
Magnifying.
Magnifying. That's the same as enlarging. Why do you think it's making a straight line? Because what? Multiplied. Somebody grab their notes. Open their notes from last week. There's a word. There's one word. We talked about it. We watched a video about it. Yes, sir?
Reduced.
Okay, reduction. So we know that dilations can either be enlarged or reduced. There's one word I'm looking for, though. Yes, ma'am. Okay, they're similar. What does that mean, similar? Not congruent. Congruent and similar aren't the same thing, remember?
Yes.
Not corresponding. Those would be congruent. There was a word that went with similar, huh? Proportional. They're proportional. That means that, remember, it's proportional. So if you have 1/2 and you have 25 out of 50, they aren't the same amount, but they're proportional, meaning they are the same what? What's that word? It's another word for fraction. Say it. It's the same ratio. It's the same ratio. So the pattern is that anytime that you have a scale factor, it's going to be proportional, or it's going to have a ratio. So what I want to do is I want to go to our notes now. So go back to your notes. This is where we are. Where's my thing so much? Okay, there we go. Look, I took big fancy notes. Ta-da! This is what I was doing last night. If y'all ever think that Ms. Gode does not do her work. Okay, so to dilate a figure on the coordinate plane, multiply the x and y values of each ordered pair by the given, what do y'all think we're going to multiply by? Scale factor. Good job. So we're going to multiply it by the given scale factor. the given scale factor. Okay, so describe what would happen if the scale factor is greater than 1. Yes, ma'am. It would get bigger. So the image would be bigger than the original. So the image would be bigger than the original. Okay, so describe what should happen if the scale factor is less than 1. The image would be what? Would be smaller than the original. Everybody good with that? Smaller than the original? Okay, so let's look at this. When dilation has occurred on the coordinate plane, you can find the scale factor by choosing corresponding sides. Okay, question. Corresponding sides or vertices. What's a corresponding side? So like if I draw a little square and I draw another little square, well, they're really rectangles. The corresponding side would be this. And if I was looking for a corresponding vertices, they would be matching vertices. Whatever's matching. Got it? Okay, so what we need to know is that we're setting up a ratio. Ratio is another word for what? Fraction. I'm going to put that under here, fraction, because we want to write it in a fraction form. And it's going to be the what over the original? The what? It's going to be the new over the original or the image over the pre-image. I like to just say the image over the original. Makes sense to my brain. But if you like new over original or image over pre-image, you are welcome to do so. We good? Okay. I highly suggest that you take out some color pencils or some highlighters or something that would be colorful. The reason why is because it helps your brain to be able to do what they need to. I'm going to ask you a question right here. How do you think scale factor is related to dilations? How do you think scale factor is related to dilations? Yes, sir.
How dilations even operate?
Okay, so we wouldn't be able to do dilations if we didn't have a what? A scale factor. Our scale factor determines what our dilation is going to look like. Okay, it gives us our rules of what's happening. So they want us to dilate. They want us to dilate the rectangle shown by a scale factor of 1/3. So they want us to dilate this rectangle shown by a scale factor of 1/3. So I'm going to highlight my original. All of my originals are going to be in orange, and all of my images all of my images are going to be in blue. The first thing I should do before I do anything else should be to do what? It tells us in the directions. What does it tell us to do? Okay, so this is my original. I don't want y'all to get excited because it doesn't say original. Original. It says pre-image, but we're going to go ahead and say it's the original. And we're going to label each coordinate point. Okay, so who can tell me A? What? Negative what? Are you sure? -6, comma 3. Okay. Next one. Who can tell me B? Yes, sir. What, William? 6, comma 3. Okay? Who can tell me C? 6 what? -3. And who can tell me D? -6, comma, -3. So all we did was we looked at our rectangle and we figured out where the corners of him lived. Do y'all see that? Now what we're going to do is we're going to take each thing and figure out what to do next. But here's the question. They want us to represent the dilation algebraically. Well, what does that mean? What's algebraically mean? Some kind of equation, right? So I have a question. If the scale factor is 1/3, how can we use it to calculate our image? If the scale factor is 1/3, how can we use that to calculate our new image? Multiply what? We're multiplying the scale factor times our original image. So that means that, what's our scale factor? 1/3. And what do we have to multiply that by? The original what? But how do we do that? Okay, what were you saying, Joelle? Each coordinate. Okay, so 1/3 has to multiply times what? Just the whole thing? X, and then it also has to multiply times Y. So, algebraically, it looks like this. We're taking 1/3 and we're multiplying times the X coordinate, and we're taking 1/3 and we're multiplying it times the Y coordinate. So this can look a little different because you're going to have a lot of information that you're going to be writing out. This is how Ms. Goday decides that she's going to do this. And the reason why I do it this way is because I have to make sure that I'm not making any mistakes. Okay, so we're going to take each single X coordinate and Y coordinate, we're going to multiply it times the scale factor. The way that we do this is that we are going to take A prime, and that's going to be 1/3 times -6, comma, 1/3 times 3. And that's going to give us our image. B prime is going to be the same thing. 1/3 times 6, comma, 1/3 times 3. C prime, 1/3 times 6, comma, 1/3 times -3. D prime, 1/3 times -6, comma, 1/3 times -3. I'm just writing out everything that I'm going to be doing. If you can do it in your brain and on calculators, that is okay, but I want you to double check because this is what we're going to be looking for whenever we're seeing if your work is correct. I write it down. Look, you'll see. I wrote all of it down because I wanted to make sure I didn't make any mistakes because I make simple mistakes when I'm multiplying and dividing. Look. See? Ms. Goday wrote all of the notes because I want to make sure that I'm getting them correct. Okay? So I suggest that you do that too. Ready? 1/3 times -6. 1/3 times -6. Well, what's -6 divided by 3? -2. Okay, what's 1/3 times 3? What's 3 divided by 3? Ta-da! Okay, B prime. What's 6 divided by 3? And 3 divided by 3? Okay, C prime. What's 6 divided by 3? 2. What's -3 divided by 3? -1. And D prime. What's -6 divided by 3? And what is -3 divided by 3? You okay? So watch, I'm going to go ahead and plot it because it makes my brain happy. -2, 1. Then it says 2, 1. Then it says 2, -1. Then it says -2, -1. So here is my new little baby rectangle. Look how tiny he is. So what we're doing is we're dilating on the coordinate plane. Okay, so for this one, I want you to develop a logical explanation of why the corresponding sides changed the way that they did. So I know it says compare the ratios of corresponding sides. What do you notice? But Ms. Gode wants you to understand this question. Develop a logical explanation of why the corresponding sides changed the way that they did. A logical explanation of why the sides changed the way that they did. What would y'all say? Yes. Develop a logical explanation of why the corresponding sides changed the way that they did. And I want you to turn and talk to your neighbor about it for about a minute. You get a minute. So you're explaining why the corresponding sides changed the way they did. Okay, what did y'all discover? Okay, anybody notice anything different? Yes, ma'am. Okay, it's a similar figure. Anything else? Did anybody think, well, it's just divided by 3? Did you say that? They're all divided by 3. Look at them. So if you multiply it by a scale factor of 1/3, everything just got divided by 3. 6 divided by -6 divided by 3 was -2. 6 divided by 3 was 2. 6 divided by 3 was 2. -6 divided by 3 was -2. 3 divided by 3 is 1, and so forth. Do y'all see the pattern? So when we're looking at this, we want to pay attention to details. The last question, did the dilation change or preserve the orientation of the figure and the orientation of the vertices? So basically it's asking, did it change all of the sides in comparison to the other one, or did it change, or did it keep it? So did it change or did it keep it? Like, is it still the same rectangle? So it's preserved. So we preserved the orientation of the figure and the vertices. So the dilation preserved the orientation of the figure and its orientation. Figure and its vertices, sorry. Okay, so what I want you to do is, as a group, I'm going to give you 5 minutes to do number 4 and 5. 5 minutes to do number 4 and 5. What'd you get for number 4? What'd y'all get for number 4? What were your images coordinate points? Okay, hold on. E was what? -8, 4. Negative 4 comma 2, right? Okay, so here we go. What do you have for F? 4 comma, I'm doing the pre-image, guys. 4 comma 2. Okay. G, 3, negative 1. H, negative 3, negative 1. What was my scale factor? What's my scale factor? 2. So we are going to multiply everything by 2. We're going to multiply our x coordinate by 2, and we're going to multiply our y coordinate by 2. Yes? So here we go. Negative 4 times 2. Negative 8. 2 times 2. Beautiful. So this is E prime. Then we have 4 times 2, which is, class, can y'all help me with this, please? 4 times 2, 8. 2 times 2, 3 times 2. Negative 1 times 2. Negative 3 times 2. Negative 1 times 2. So we have GH. Okay, is this what y'all got? So, this is not what you got? Who did not get this? Anybody? Okay, so we have EFGH, and if we were to draw our dilated, he would be bigger or smaller? Bigger? He would be bigger, right? So we are going to be a bigger shape. So that means that we're going to be at negative 8, comma 4. Here's our E. Then we're going to be at 8, comma 4. Here's our F. Then we have our G, which is 6, negative 2. And our H, which is also negative 6, negative 2. So our shape, our new shape, will look something like this. Yes? Did it preserve the sides? Did it preserve the vertices? Yes, it is the same what? It's the same shape. It's similar, which means it's proportional. It's proportional. You have the same shape. He's not changing, besides the fact that Ms. Gode drew it all funky. Other than that. Okay, what y'all get for I as the original? I, J, K. 0, comma 4. J, 4, comma negative 2. K. Okay, and then what is our scale factor? Okay, so what would my algebraic representation of this be? Everybody okay with this? This is our algebraic representation of it. So if we were to do all of this math and we were trying to check and make sure that we could do it all correctly, we would multiply each x and y by 3 over 2. So ready? 0 times 3 over 2. 0. 4 times 3. 4 times 3. 12. 12 divided by 2. 6. I'm showing y'all how y'all can do it in your brain. Ready? Watch. 4 times 3. 12. 12 divided by 2. 6. Negative 2 times 3. Negative 6. Negative 6 divided by 2. Negative 3. Negative 4 times 3. Negative 12. Negative 12 divided by 2. Negative 6. Ready? Negative 2 times 3. Negative 6. Negative 6 divided by 2. Negative 3. Okay? So if we were to plot this on our graph, it would be at 0, 6, 6, negative 3, negative 6, negative 3. How are we doing? Okay, ready? Now we're going to figure out how to find the scale factor. Now we're going to figure out how to find the scale factor. What's the rule of the scale factor in order to find the scale factor? What do you have to do? Divide what? The what by the what? The image by the original. So we're trying to figure out what the image is compared to the original. So I'm going to use two different colors because I want you to see the difference. So I'm going to, this is my original, and this is my image. I have a quick question. If we are looking for scale factor, do I have to use all the vertices? Hey class, if I'm looking for scale factor, do I have to use all the vertices to find the scale factor? Yes or no? Why not? Because if you find what? If you find the scale factor for one vertex, it should be the same for all of them, right? Yeah. Okay, so let's look at it. What point do y'all want to use? M? M. Okay, so we're going to find the original M. The original M, what's his coordinate point? 4, comma 4. What's our M prime? M prime is 5, comma 5. Yes? So now what's the formula that we're going to use in order to be able to determine what our scale factor is? Image over what? Original. If you get caught up on that, turn the page over, look at the top. Okay? So image over the original. What's our image for X? 5. What's our original for X? 4. So guess what our scale factor is? That's it. You're just trying to figure out what your scale factor is. Is anybody not understanding what we just did? We took our original and we divided it by our image. So image divided by original gives us our scale factor. Okay, let's do the next one. What do I do? How do I set this up? Here is my original. Here is my image. What do I need to know? So, what do I do first? Find some coordinates. Okay, which coordinate do y'all want? P, Q, or R? P. Okay, let's go with P. So, the original P is what? 0, comma 3. And my P prime is what? 0, comma 1. Okay, so question you need to ask yourself, is my image getting smaller or bigger? Smaller. So what kind of number are you going to have? A less than 1. What's a less than 1 number look like? A fraction. So we're going to have a fraction. So question, what do I do if I have 0 divided by 0? We're going to get 0. So would that be a good number for us to choose? No. So explain why the scale factor wouldn't be 0. It would not be a thing. Everything would be disappeared. It'd be like poof, gone. But what information should we take? We should take the image over the what? Over the original. And we're going to take the y coordinate at the moment. So what's our image? 1. What is our original? 3. Is that a fraction? Then this is your scale factor. Okay, what happens if we just have coordinates? What happens if we just have coordinates? Can we just take the coordinates and figure out what our scale factor is going to be? It's amazing. It's actually like super easy. It's super cool too how it works. Ready? So which one are we going to take and put at the top? You want X or Y? X or Y? Okay, raise your hand for X. Raise your hand for Y. Everybody said Y. Okay, we doing a Y. Y. Okay, here we go. So we're going to take our image. Which one's our image? The prime or the one without the prime? Prime. Okay, so our image divided by our original. What's our image? 8. Divided by our original, which is 12. What's 8 divided by 12 simplified?
2.
Okay, question? Can 8 be divided by 2? Can 8 be divided by 4? Can 12 be divided by 2? Can 12 be divided by 4? Yes. If we divide them both by 4, what do we get? 8 divided by 4 is 2. 12 divided by 4 is 3. This is our scale factor. Okay, number 9. Which one you want, X or Y? X. Okay, ready? So we're going to take our image and divide it by our original. What's our image amount? 12. What's our original amount? 10. 12 divided by 10, let's simplify that. 6 over 5. Question, are we enlarging or reducing? Enlarging. Why? It's bigger than 1. Okay, last one. Number 10. Which one you want, X or Y? X. Why don't we want Y? It's 0. And explain why the scale factor can't be 0. Because nothing would happen. It would just be gone. Okay, so we're going to take our image, which is -9, divided by our original, which is -1. What's -9 divided by -1? -9 divided by -1. A negative divided by a negative is a positive. So what's my answer? 9. Okay, so what you're going to do is you're going to summarize today's lesson in this little snippet right here. But I do want you to go back into your book real quick. So we're going to come and summarize the lesson in just a second. I want to give you one problem in your book. Okay, go to page 110, number 10. Page 110, number 10. Where's my paper? Page 110, number 10. I do not want you to freak out over number 10. It looks scarier than it is. Okay, so what we're going to do, we are going to look at this image and we are going to determine its scale factor. We're going to look at this image and we're going to determine its scale factor. We're going to do the exact same thing we've just been doing. So what I'm going to do is I'm going to make sure that this is my image. So A prime, B prime, C prime. And then I'm going to have A, B, C as my original. My goal is to figure out what my scale factor is. Here is your question that you need to ask yourself. Analyze the image. Do we need to use all pairs of corresponding vertices to find the scale factor? So, analyze the image. Oops. Do we need to use all pairs of corresponding vertices to find the scale factor? explain your reasoning. So what I'm going to do is I'm going to give you 2 minutes to talk this over with your groups and to solve this problem. You may go. So, what did y'all say? Do we need all pairs of corresponding vertices to find the scale factor? Why not? Explain your reasoning. Explain why not. Is it necessary?
You can find it with just the lights.
Just the what? What did y'all say?
The same skill factors.
Say it again.
The same skill factors used on every point, so just finding one.
That's a good explanation. He said that the scale factor is going to be the same on each corresponding part. So if you find one, you should be able to find them all. That's a good explanation. So what did y'all figure out the scale factor was? 3. So they took the original and they multiplied it by 3? Yes? Okay. So what we're going to do is you're going to do the exit ticket. The exit ticket is going to be for mastery. It's a 10-point mastery. It's page 111. Real quick, before you start your mastery exit ticket, you're going to do this page for homework. This page for homework. And then at the top of that page, I want you to write page 117, numbers 6 through 14 as well. 6 through 14 as well. So exit tickets right now, and then this is what we're going to be doing for homework. This page and numbers 6 through 14 as well. When you're finished with your exit ticket, you may work on iReady. You have your 2 iReady lessons due by the end of the week. And then you may start your homework if you finish your iReady.